focus. And we're not going to, like, you're not going to listen to me talk for 20 minutes. We're going to get through an example so I can show you how to do one, and then you're going to practice some before we move on to the next example. So you'll be able to move around a little bit here in a little bit. All right, so the standards. That you can graph quadratic functions by hand and determine the domain and range. The extension to that is that you can explain the slight differences between graphing each form, because there's actually 3 different ways a quadratic can be written and represented. And you have to also be able to tell me why we have multiple representations of a quadratic. So not every quadratic or parabola is written the same or represented the same way every single time. And there's reasons for that. So the extension would be able to tell me the reasons for that. All right, so in this standard, we learned how to graph quadratic functions that might be represented in 3 different ways. Part of this standard is knowing how to recognize what representation you have, and then what gives you a clue, or once you recognize what representation you have, then you know how to start graphing it by hand. Knowing how to do this will assist you in further standards down the road as well, since many of the skills we use here are reflected in those as well. So this is a foundational piece for some of the other functions that we have to graph later. A lot of stuff we do here, we do later. So we're going to start with the different ways to represent a quadratic. Some of these you've already looked at. Standard form. Can anybody just spout it off without looking at anything? Ax squared plus what? Plus bx plus c. Okay, we'll fill out the characteristics here in a minute. The vertex form. No, well, that's how to find the vertex. That's good. But the vertex form is the one that looks really similar to our absolute value one that we graphed before. The only difference between the absolute value one and this one is the function on x has changed from absolute value bars to a square. That's what makes this a quadratic. And then the intercept form. Looks like this. Now, we're going to learn how to graph intercept form, but it's going to make a little more sense why we need this type of representation when we do the next standard. All right, so let's go back to characteristics. When something is written in standard form, one characteristic that you can always pull out of it is that the vertex, the x-coordinate, is the value x equals negative b over 2a. The reason that doesn't work for the other 2 forms is you don't have a b, or you have an a, but you don't have a b value in either one of the other ones. Okay, in the vertex form, the reason it's called vertex form is you can easily pick out the vertex, because the vertex is your h and your k value. The intercept form, what do you think, or why do you think it's called the intercept form? It shows the 2 intercepts. So it's because with a parabola, if you have a U-shaped curve, how many times is it going to connect with the x-axis? Twice. If it connects once, what's going on? If this is my x-axis and it only connects once,
that's the vertex.
That's the vertex that's sitting on the x-axis. Good. Okay, so the intercept form our intercepts always end up being P and Q. Now, if we wrote them as ordered pairs because they're intercepts, that's showing that they connect with the x-axis at those 2 points. In all cases, and you can write this really anywhere, if your A is greater than 0, you open up. If A is less than 0, you open down. Why do we not have an equal to bar in either one of those cases? Anybody? It'll never be a line. If A is 0, what happens to that first term? Gets rid of it, and then you have a linear. so we no longer have a quadratic. So you can't have a b 0, but if it's greater than 0, so positive, you open up. If it's negative, you open down. Okay, so these are the three we're going to focus on today. Why do you think we have three different forms? What would you need to recognize each form? We're going to fill these out after we do the examples, because I think we'll be able to pull more brains than just mine to answer those questions once we go through some of the steps. So, go ahead and flip. Okay, so we're going to start with standard form. Now, I should say that you can graph anything ever you want, no matter if the equation is crazy. You can graph anything by making a table of values. It's usually easier if you have some type of method, so you don't have to generate like 20 values to plot. So standard form, there's a certain way we graph something when it looks like it's in standard form, another way that we graph when it's in vertex form, and it's not to make it confusing and make it more steps and more things you have to remember. It's just, it usually cuts down on the work so you don't have to FOIL stuff out and make a table of values every single time. And we do practice them enough that you're comfortable with all three. Okay, so graphing standard form. First of all, let's go ahead and write down what standard form is. Just so you know. Like you found in the web quest, our first step here is going to be focusing on the vertex. So we're going to start by finding the x-coordinate of the vertex. And how do I find the value of the x-coordinate of the vertex? We've written it down a couple times already. Negative b over 2a. In your web class, you saw that that gives you the x-coordinate. And then, I think I mentioned that on the previous page. So find the x-coordinate of the vertex by finding the value of x equals negative b over 2a, where the b and a are already in your equation. It's just the numbers in front of your x's. Okay. Then we make a table of values by picking x values that surround the vertex. The reason we start with the vertex is because if you don't start with the vertex and you just randomly start picking points, you might only get points on one half of the parabola. So we need points on both sides, and so we start with what I call the most important point, or one of the most important points in a parabola, which is the vertex. And then we kind of build our table around the vertex, because then we're sure to get points on either side so you can see the curve. Okay, so once you make a table of values, then you're going to plot your points. Connect with a smooth curve. And then what do you think the other thing is that we do here, that we did with absolute value function? Very end. Domain and range. Good. So we determine the domain and range. And it's always easier to determine the domain and range after we graph, because then we can have a picture to look at. Okay. First one we're going to look at is y equals negative 2x squared plus 5x minus 4. All right. Another thing that I just like to kind of throw out there is, what direction is this going to open? Is it going to open up or down?
Down.
It's going to open down because my a value is negative. That might be something just to indicate right off the bat, because sometimes our points get screwy, and if it's not opening down like it should be, we know we did something wrong, either plug something wrong into the calculator, or we just know there's an error somewhere. All right, so I'm going to label my steps in my example. You wouldn't have to label your steps. I just want you to be able to match what we're doing down here with what our steps are up there. So we're going to find the x-coordinate of the vertex by finding the value of x equals negative b over 2a. What's my b value here? My b value is 5. So we're going to have negative 5. And then my a value is negative 2. So I get 5 over 4, which would be 1 1/4, but we're going to leave it as 5 over 4. And then I'm going to make a table of values. And when I make my table of values, I like you to pick 2 points to the left, 2 points to the right. And where do you think that 5/4 is going to go? Am I going to put it here and then pick 4 points to the right? No, we're going to put it in the middle because we want points on the left and the right so we get both sides of the parabola. So I stick that 5/4 right in the middle. And then I don't want you to pick crazy points to the left or the right. Like pick whole numbers. So if this is 1 1/4, what's the whole number directly to the left of 1 1/4? To the left. 1, and then what's the next whole number? 0. So we're going to pick nice numbers. 0 and 1 to the left, and then 2 values to the right that are whole numbers will be 2 and 3. Okay. Now, so you don't have to plug in 5 points all separately. I want you to get a calculator if you don't already have one out. And we're going to review how to use your table feature. That table feature will save you lots and lots of time. I don't want you to waste time when we're learning new things like this, just plugging in points. Like I know you can plug in points. So I want this to be quick. A couple of reminders when you're using your table feature. You have to put the function into y equals. So go to y equals. If something's there, clear it out. If your plot is highlighted, you'll need to make sure it's unhighlighted. Otherwise, the calculator is going to get confused. And what do we put into y equals? That equation there. So we have negative 2x squared plus 5x minus 4. Okay, so that should be in y equals. Are we okay? Okay. Just so that we double check our table setup, does anybody remember where the table setup is? Second window. Good. So if we go to second, and then go to window, in order to plug in your own points, which we want to plug in I want to plug in my own points there because I only need 5 points. It needs to say ask and then auto. Does everybody say ask and then auto? Very good there. Okay. It's rare that we ever change that, so it should always say ask and auto. What? Let me know when you're ready. The next step there, once you have your table set up the way it should be, go to second and graph. Now I have a bunch of points in there. Does anybody remember what button to push to get rid of all the points? Like if you have points in there already. I don't think clear works. No. Delete. So that's the difference between, like, when you put in lists of data, you don't want to push delete, you want to push clear. Or this one, since it's generating a table automatically, you can push delete. And then in your X column, you're going to put in those X values. So go ahead and do that now, and then copy it down on your paper. Okay, I'm sure that somebody else has this question too, so I forget that we haven't done a fraction here before. When you put in 5/4, you just do 5 divided by 4, and then it automatically puts it as a decimal. Now, I'm not going to expect that you convert this to a fraction, so whatever the y value is there, you just put it into your little table. Okay, so we have negative 4, negative 1, negative 0.88, negative 2, and negative 7. Now, because parabolas are very symmetrical, a lot of times you'll notice that when you find these extra points here, that they end up being the same y values. But sometimes they don't, like here, and that's because our x coordinate isn't like it's at a weird place. It's at 1.25. So it's fine that our points don't match up because when we graph them, we'll still be able to connect them, and it'll still make a parabola. Okay, so go ahead and plot those 5 points, if you would. I don't think we have to change our scale at all. Remember, 5/4 is like 1 1/4. Okay, so when I graph those 5 points, that's what I got. Okay, so even though my points are a little off, did everybody end up having the same picture that I do? Up there? Okay. Even though my points are a little, or they look a little bit off, if you connect them with a smooth curve, should not be a V shape like our absolute values, it should be a U-shaped curve. You are able to connect the points to make a U. They're not like a huge outlier or something, one of your points to end up way out in no man's land. They do end up being able to be connected. Alright, and then our third step here will be to do domain and range. Now, did we plug in, oh, actually for this one we didn't plug in, but did we plug in 0? Sure. Could we plug in a negative number and have it work? Yeah, we could plug in a negative number and get a number out. And we plugged in a positive. So there's no numbers that we would not be able to plug in. So what should domain be? All real numbers. You can plug in fractions, decimals, negatives, zeros, positives. Yes?
No, we're supposed to do all decimals or all fractions.
What was that?
I thought we were supposed to do either all decimals or all fractions.
Are you talking about the table?
Yeah.
I said that in the table, like when we were graphing before you came across a fraction, I did say it was fine for you to make it a decimal just so you knew exactly where to put it. So since your calculator gives you a decimal, that's fine that you put that in. It's just usually when you're solving and stuff, I don't want a decimal because we have to round. And then the range, your parabola does end at a certain y value. What's that y value that it ends at? Like it doesn't go above it. Negative 0.88. It's going to be the y value of your vertex where it ends. So your your range should be y values. Now is it greater than or less than here? It's going to be less than because you're opening down. Less than or equal to negative 0.88. And if you want to draw a little arrow, it should always match up with the y value of the vertex. Because your vertex is either the highest point or the lowest point. Okay. I think we have time to try one of these on a whiteboard. Actually, scratch that. I'm going to have you do your exit ticket. Because I think we only have I think the bells are not lined up with my phone time. So I want to make sure I'm done. So we are going to practice this a lot tomorrow. You do have a homework video tonight to finish out the vertex form and the intercept form, so it won't be a very long video, but you will need to watch that tonight so you're ready to practice tomorrow. Your exit ticket, I want you to answer 2 questions. One of them is about your test. Okay, so you should be on the back side of your exit ticket. The first question is about your test. Now that you've taken a test and you've gotten one back that's been graded, how fair do you think the test was? Like the questions that I asked, how fair do you think it was? Like how well did it match what we practiced? Or did you feel like it was harder or not as hard or whatever? So how fair do you think the test was? And then how fair do you think it was graded? And that's good feedback for me as your teacher to know how you're feeling about that. So how fair do you think the test was? Why or why not? If you didn't think it was fair.
had to do it so he proved he was innocent. So
So he what? To prove his innocence?
yeah, it was good. It was good. He wasn't a bad guy. He was a good guy.
Okay. Stole a diamond, but yeah, it's not